All right, today we're pulling back the curtain on the tiny, unsung heroes of our modern world, proximity switches. You might not know it, but these little devices are the secret sauce behind everything from a soda can getting filled just right to your car's parking sensors saving you from a bump. So, have you ever really stopped to think about it? How does a bottling plant, for instance, count thousands of cans an hour without ever physically touching them? Well, the answer lies in a really clever piece of tech that acts as the eyes and ears of the machine. And it's not just in these massive factories, it's all around us. How does an elevator know it's hit the perfect spot on your floor? Or what about the automatic doors at the grocery store? Even your smartphone, that screen turning off the second you put it to your ear? Yep, the secret behind all of this is one small but incredibly powerful component. And here it is, the proximity switch. The keyword you need to lock in your brain is non-contact. See, unlike a button that you actually have to press, these switches sense objects from a distance using invisible fields. And that one simple idea, it completely changes the game for automation. Okay, so what's the big deal about being non-contact? Why is this no-touch capability so revolutionary? Let's break down exactly what makes it such a game changer. Well, think about it like this. On one side, you have your old-school mechanical switch. It has to physically hit something to work. And what happens when things make contact over and over and over again? They wear out, they get stuck, they break. But on the other side, you've got the proximity switch. It just senses that something is there, creating a signal without ever making contact. No touching means no wear and tear. And the reason they're so incredibly reliable is just brilliantly simple. Zero moving parts, right? There is absolutely nothing to jam, nothing to break, nothing to wear down. And that means their service life is dramatically longer, saving factories a fortune in maintenance and downtime. And what about speed? Oh, let's talk about speed. This number, 5 kilohertz, means it can switch up to 5,000 times a second. That is ridiculously fast. It's fast enough to detect individual pills dropping into a bottle on a high-speed packaging line without missing a single one. It's basically like giving the machine superhuman reflexes. So when you put it all together, their incredible durability, that blistering speed, and the fact that they're resistant to harsh stuff like water, oil, and dust, you get a nearly perfect sensor for the toughest industrial jobs you can possibly imagine. But here's the thing. You can't just use one sensor for every single job, because not all targets are made of the same material. Proximity switches actually come in specialized types, and each one is designed for a specific task. This chart lays out the options beautifully. Let's say you need to detect metal engine parts on an assembly line. An inductive sensor is your go-to. What about sensing the level of grain inside a giant silo? A capacitive sensor can do that. It can literally see right through the non-metallic wall. Then you've got photoelectric sensors that use beams of light for everything from garage doors to making sure a package is in the right spot. And finally, ultrasonic sensors use sound waves to detect almost anything, even tricky stuff like clear glass bottles. Okay, so we know what they are and what they do. Now for the practical part. How do you actually connect them so they can talk to a machine's brain, like a programmable logic controller, or PLC? Thankfully, there's a standard color code that makes life a whole lot easier. For just about any DC sensor you'll find, brown is your positive power, blue is your negative or ground, and black is that all-important signal wire. This is basically a universal language for technicians, so you can quickly and confidently wire up any sensor no matter who made it. Now, we're going to tackle a concept that can seem a little tricky at first, but I promise it's actually pretty straightforward once you get the basic idea. It all comes down to how the sensor sends its "hey, I see something" signal down that black wire. Think of it like this. A PNP sensor is sourcing. When it detects an object, it pushes positive voltage out to the load. An NPN sensor is sinking. When it triggers, it pulls the load's connection down to ground. One pushes, the other pulls. Just remember that. And this table here shows you exactly why that push or pull logic is so critical. It determines where you have to connect your load, whether it's a warning light or a PLC input. For a PNP sensor, the load goes between the black signal wire and the blue ground wire. For NPN, it's the other way around. And you have to get this right, because if you don't, your circuit simply will not work. And this brings us to the golden rule. You absolutely must match your sensor type to your controller's input type. A PNP sensor needs what's called a sinking PLC input, and an NPN sensor needs a sourcing one. If you mix them up, the signal might be sent, but the controller will never hear it. It's like they're speaking two different languages.
So you've got it all wired up, but something isn't working right. How can you quickly test if the sensor itself is the problem, right out there in the field?
Here's a simple 3-step field check. First, just look at it. Most sensors have a little LED that lights up when they detect something. That's your first clue. Second, grab a multimeter and confirm it's actually getting power across the brown and blue wires. And third, check if that black signal wire is sending out a voltage when the sensor is triggered. This simple process can help you diagnose most common sensor issues right there on the factory floor. So, to recap the really important stuff, proximity switches are non-contact, which makes them incredibly fast, reliable, and durable. You have to pick the right sensor type for the specific material you're detecting, and finally, you absolutely have to match the sensor's output logic, PNP or NPN, to your controller. And that brings us to a final thought. These sensors are already the invisible backbone of automation. So as they get even smaller, smarter, and more integrated, where are we going to see them next? From smart homes that anticipate our needs to autonomous vehicles that navigate our cities, the future of non-contact sensing isn't just beginning, it's already here, quietly shaping the world around us.